In the previous lecture, we defined almost sure convergence as a strong form of convergence. And it is actually quite trivial to show that almost sure convergence implies improbability convergence, because improbability convergence says the probability that the sequence deviates from x, the sequence xn deviates from x, goes to 0, whereas almost sure convergence says that the probability that the sequence goes to the probability of outcomes or of realizations where the sequence of random variables converge to the distribution x is 1. So showing this is quite trivial, and I suggest you do this as exercise. Now, an equally interesting question, a more interesting question perhaps, is whether or not almost sure convergence is stronger than mean square error sense convergence. The answer to that is no, and the converse is not true either. So we'll see in this example, we'll see that almost sure convergence does not imply mean square error convergence. In another example, in further lectures, we will see that mean square error convergence does not imply almost sure convergence. Okay, so as an example, we'll study the double or nothing game. Imagine this game where I start with a given amount of fortune, a sub 0, and at every round of playing the game, I win or lose with equal probability, independently from round to round. If I win, my money is doubled. It becomes 2a0. If I lose, I'm bankrupt and I leave the game. Again, if I win, my money is doubled again. If I lose the second round, I go home with the 0 money. Okay, so this is a quite trivial game. It is easy to see. Well, first of all, let's let an be my fortune after n rounds of playing this game. An is equal to 2an minus 1 with probability 1/2, and 0 with probability 1/2. Okay, so now the probability of outcomes where an goes to 0 is 1 minus the probability of the intersection of events that I win the nth round as n goes from 1 to infinity, because only on those outcomes where I indefinitely win does my money not go to 0. Okay, so now the probability of this event is clearly 1/2 to the n by independence of each round. Hence, 1 minus 1/2 to the n goes to 1 as n goes to infinity. All right, so this actually is not a limit. Let me clarify this. This is basically equal to 1 because the limit is inside the probability. Okay, this is a probability 1 type convergence. Now let's see if the fortune an, converges to 0 in the mean square error sense. In order to do that, we need to consider the mean square error, which is the expectation of an minus 0 squared. Okay, which is the same thing as the expectation of an squared. Okay, now we can use iterated expectations to answer this. We can write expected an squared as the expectation of an squared given an minus 1. Right? And given an minus 1, expectation of an squared is simply 1/2 times 4an minus 1 squared, because with probability 1/2, an is twice an minus 1, so it squares 4an minus 1 squared. Right. So then this is twice the expectation of an minus 1 squared. Now, by iterating over n, it is easy to see that in general, the expectation of an squared goes like 2 to the n a0. If a0 is a positive amount of money to start with, the expected square of my fortune actually goes up to infinity. So an does not converge to 0 in the mean square error sense. Does not converge to 0 in the mean square error sense. On the other hand, an converges to 0 in the almost sure sense. So this shows that almost sure convergence does not imply mean square error convergence. We already know that almost sure convergence implies improbability convergence, and mean square error convergence also implies improbability convergence. So perhaps we can draw this relationship of situations where mean square error convergence exists, sequences that converge in the mean square error sense, and almost sure sense do not imply each other. Mean square and almost sure convergence do not imply each other, but when one of these exists, improbability convergence always exists. So improbability convergence is a strictly weaker form of convergence, and this can be seen in this diagram. So let me put this in a box. Mean square and almost sure sense of convergence always imply improbability convergence, but they do not imply each other.